Hello, this is the last cluster for the 7th grade on statistics and probability. If we take a look at all the different topics that we have to cover, it's quite lengthy. So I just want to let you know that there is not, outside of the regular project discussion board, the homework for this lesson is the only one that you'll have attached with it for this week outside of watching the lesson videos. So be patient with yourself as you go through these. Feel free to always ask questions if you need to. So let's get going. The more random a sample, the more likely it is to give an accurate depiction of the entire population. There are multiple strategies to acquire a random sample while avoiding biases. Ms. Poor is going to plan a unit based on student interest. Without surveying every student, what are some ways that she could generate a random sample? One way would be called a systematic random sample, such as every 5th student, or every 3rd student, or every 10th student. We could also do a stratified random sample, such as splitting students into groups, such as 6th, 7th, or 8th graders, boys and girls. You could split them up by their heights or their shoe size as an example. Then a certain number of students is randomly selected from each of those stratified groups. We need to avoid biases of convenience. Those would be convenience samples, such as selecting the first 5 students who enter the class. Yes, this is easy and simple, but is an accurate depiction of all the students in the class. Or a voluntary sample, such as who wants to participate in the survey. This is easy and does avoid conflict, but is an inaccurate representation of everybody. The school board needs feedback from your parents about parent-teacher conferences this year. Help the school board out by devising a random sampling strategy and explain how to avoid biases. The school board should randomly select 50 students from the student body and mail a survey home to those addresses. This avoids the bias of convenience, where they may only survey parents who come to conferences. Further, if each school board follows up with each mailing, then it also eliminates the voluntary bias of getting data from those who choose to participate. Inferences can be made about a large population by discovering characteristics of smaller representative sample. We can make inferences about a population using data from representative samples and proportional reasoning. Paige has scored the following point totals in the first fourth of the season. The school's single season record was set by someone who scored 166 points in her first 11 games. Is Paige going to break that record? Provide an example with reasoning. So far, her total points is 77, so I added 14 plus 5 plus 17 plus 15 plus 26. This represents a fourth of her season. So therefore, each fourth, we're going to assume that she does 77 points each fourth of the season. So 4 times 77 would say that she would score 308 points through the season. Let's say there's a 20-game total. So the single season record was held by someone who did 166 points in her first 11 games. So on average, that student completed 15.1 points per game. So if I multiply that by 20 games, that would be 302 points. This assumes that particular girl maintained her average throughout the remaining of the season. So therefore, Paige is certainly on her way to breaking the record because she is we assume if she stays on the same path that she will get 308 points. Paige's next 2 games are shown below for games 6 and 7. If the actual season scoring record is 299 points, is Paige still on pace to break? Explain using the new data. Well, Paige's new average would be 77 plus 11 plus 14, so 102 points over the 7-game stretch. That says that she makes 14.6 points per game on average, or the mean. So if we were to take 14.6 times 20 games, that would give her 292 points for the season, assuming she has the same average throughout. This new data brings her mean points per game down, and since 292 is less than 299, she is not on track to break the single season scoring record. How many home runs will be hit in a 15-year career? We have the 6 seasons listed and home runs listed below. So the total home runs, if we add them all together, is 121. Breaking that down per season, it is 20.2 mean home runs each season. Multiplying that by 15 seasons, there would be, assuming the home runs stayed the same, 303 home runs in a 15-year career, assuming that each season, this particular baseball person's mean stays around the same. Mrs. Romero's class competed with Mr. Nelson's class in a discount card fundraiser. Individual sales are below. Whose class had the best participation? We can use the mean and the mean absolute deviation to make comparisons between these two populations. Let's use the mean and mean absolute deviation to support our opinion. So the mean for them, again, is to add them all up and divide them by how many there are. So the mean for Mrs. Romero's class is 4.9. And the mean for Mr. Nelson's class is 4 1/10. The student who sold 32 in Mrs. Romero's class is a drastic outlier and is affecting the mean for this class. So although it appears higher, does it really mean that it's higher? Therefore, it is best to calculate the mean absolute deviation to determine how varied each class data really is from the mean. So remember, the mean absolute deviation tells us how far away from the average the points are, so how spread out the data is. So I've calculated the mean absolute deviation, referred to previous videos to recall how to do that. And we get 3 7/10 for Mrs. Romero's class and 2 2/10 for Mr. Nelson's class. I can see that Mr. Nelson's class sold closer to the average than Miss Romero's class because the number is smaller. Therefore, we can say that Mr. Nelson's class had better participation since more students were closer to the mean. Processing data both visually and numerically allows for more accurate comparisons between two populations. We can also use the mean and interquartile range to make comparisons between two populations. The 10 fastest students in 7th and 8th grade at Dakota Middle School were asked to run the 100-meter dash. Use the median and interquartile range to explain which class is the fastest. So I first listed all of the times in order from least to greatest. And then I found that the median for the 7th grade class was in between 14.6 and 14.8. So that would be 14.7. In the middle between 14 and 9/10 and 15 and 2/10, we'd add them together and divide by 2 such that it would be 15 and 5/100. To find the interquartile range, recall that we split our data in half and find quartile 1 and quartile 3 and then find the difference between them. So 15 and 9/10 minus 13 and 7/10 is 2.2, and 15.6 minus 13.8 is 1.8. Sometimes it's best to look at pictures to help us identify and compare between populations. So this top one must be the 8th grade team, because if we look at the smallest number is 12.7 matches here, and the highest number is 15.9, which matches here. So this top one recalls the 8th grade team, and the bottom one recalls the 7th grade team. Although the 8th grade had the fastest runner, and the 7th grade had the slowest time, 7th grade as a whole performed better since most of the data points are more evenly distributed. Okay, there are two boxes, each with 100 bills of value varying between $1 and $50. Susan is allowed to pull a sample of 20 bills from each box, but then must choose one box to keep. Use the mean, MAD, median, and IQR to help Susan select a box. Create a dot plot or box plot to provide a visual that supports your opinions. So I have our boxes laid out. The mean or the average of each box from the bills that I pulled out were 10.15 and 10.1. Very similar. So let's move on to the MAD. The MAD for each one is 9.94 and 5.94. I can tell that in box 2, the numbers are closer to the average, the ones that I chose, and in box 1, they are more spread apart. The median is 5 and the median is 7 and 5/10. So the median is larger in box 2. The interquartile range is 9 and 15. Let's take a look at the box plots, the dot plot for each one. Notice that the box 1, most of our data is piled up on the lower end, less than $10 range. Whereas the right-hand box 2, the majority of them is between $5 and $20. And since the mean is higher and from the dot plot, the bills are more consistently higher, I would recommend box 2. A third box is brought in for Susan to consider. Should we keep box 2 or should we select box 3? So I brought over our data, the mean, MAD, median, and IQR of box 2. Box 3, the mean is 9.85, slightly smaller than the mean of box 2. The MAD is slightly higher, so the data points are more spread out from the mean. The median is 10, and yes, that is higher. Can't really tell from here. And further, the IQR is more spread out since the range between the first and the third quartiles is 19, which is higher than the interquartile range of box 2. Because the mean is higher and its MAD and IQR are lower with box 2, we should recommend box 2 still. Box 3 is simply too variant and provides a riskier opportunity. Let's perform 10 spins with each spinner, then record our results as 10 trials and then summarize them in the frequency tables. So in our course, I kind of tried to split my screen here a little bit for you. In our course, when we click on manipulatives, I'm going to show you which particular spinner. I clicked on virtual spinner here, which brings me into this spinner. Which is a really fun spinner to use actually. Our particular one over here has only 3, so I'm going to subtract the number of sectors so that it looks similar to mine. And we want to do, we're going to spin it 10 times. So I can click spin, and the first one is blue. So I'm going to put B for blue. And then I'm going to spin again. And the second one was gray. Notice it's keeping track for us over here. And we ended up with gray again. It looks like they counted that as gray. And gray. Gray's kind of winning out here. Another gray. Oh, we got a blue. Funny, we haven't got a pink yet. Another gray. A blue. And a pink. Oops. And a pink is what we ended up with. Pink. Okay. So of the colors, I'm just going to move this over a little bit so that we can see. Of the colors, we had blue, pink, and gray. The frequency in which we got blue was 3. The frequency in which we got pink was 1, and gray was 6. Let's see what would happen if we altered this a little bit so that it matches our new different one here.